Hey y'all, it's me, Miss B, and today we're going to go over the problems from the Delta Math that was assigned to you earlier this week. So we're going to determine each feature of the graph of the given function here. Okay, and this is exactly like your Delta Math. We're just going over how to do the problems. Okay, so for the horizontal asymptote, what we need to do is we need to move this. We need to compare our numerator and our denominator, the degree. Okay, and so the degree of my numerator is 1, and the degree of my denominator is also 1. So since those two things are equal, then it's just the ratio of the coefficients. So -1 over 2. So -1/2 is equal to y, is that horizontal asymptote. We'll have a vertical asymptote by setting our denominator equal to 0. So we'll go ahead and do that, set our denominator equal to 0. So 2x plus 7 equals 0. And solve. So subtract 7. 2x equals -7. Then divide by 2. X is equal to -7 over 2. Okay, square these answers here so we don't lose them. All right, to find the x-intercept, I want to set my numerator equal to 0 and solve. So -x plus 2 equals 0. I'm going to go ahead and add x to both sides. So x equals 2 is my x-intercept. Then to find my y-intercept, I'm going to plug 0 in for all x's. So here I go, plugging 0 in for all of those x's. Move this over. Oh, geez. So we have -0 plus 2 over 2 times 0 plus 7. This goes away and this goes away, so we're left with 2 over 7, and that is equal to y. Okay, so that is how we find all of that. All right, let's go ahead and do our next one here. Move this stuff around. Let's actually copy that. Okay, so to find the horizontal asymptote, I need to compare the numerator and the denominator. I have a degree of 1 and a degree of 1. So it's just going to be the ratio y equals 4 over 3. For the vertical asymptote, I'm going to set the denominator equal to 0. So 3x plus 4 equals 0. And solve. So subtract 4. 3x equals -4. Divide by 3. And x equals -4/3. For the x-intercept, we'll set the numerator equal to 0. and solve. So subtract 13. And 4x equals 13, negative 13. Divide by 4. And x equals negative 13 over 4. Finally, for the y-intercept, I plug in 0 for all x's. So 4 times 0 plus 13 over 3 times 0 plus 4. These go away, and y equals 13 over 4. Okay, next up. There we go, that's better. Okay, horizontal asymptote. We compare the numerator and the denominator's degree. So 1 and 1. So again, it's the comparison of the two. So 5 over 2 equals y. Then we need to do the vertical asymptote. So we set the denominator equal to 0 and solve. So add 5 to both sides. 2x equals 5. Divide by 2. X equals 5 over 2. Then our x-intercept we'll make our numerator equal to 0. So 5x equals 0. Divide by 5 on both sides to get the x equals 0 as our x-intercept. For our y-intercept, we will plug in 0 for all x's. So 5 times 0 over 2 times 0 minus 5. So we get 0 over negative 5, which means y is equal to 0. Okay. Then, for this one here, number 4. There we go. All right, our horizontal asymptote, we compare the numerator and the denominator. Both have a degree of 1. So y equals 2 over negative 3, that ratio. For the vertical asymptote, I'll set negative 3x minus 9, the denominator equal to 0, and solve. The x-intercept, I set the numerator equal to 0. X equals 7 over 2. Then the y-intercept, I plug in 0 for all x's. So I get negative 7 over negative 9. So y equals positive 7 over 9 because those negatives cancel out. All right, finally on our last example, we will end up graphing it. So first let me draw my graph so I can have it ready here. Or wait, I think I can put in graph paper. Yes, okay. Okay, so for the horizontal asymptote, I am going to compare the numerator and the denominator. They are both 1, so y equals negative 2 over 3 is that graph. So that is a line. So So I'm going to go down here and graph negative 2 over 3, just like right here, that horizontal asymptote, and I'm going to make it that a dotted line. Okay, so there's my horizontal asymptote, and I'm going to go ahead and label it as such. All right, my vertical asymptote, I'll set the denominator equal to 0 and solve. Add 4, 3x equals 4, divide by 3, x equals 4 over 3 for the vertical asymptote. So I'm going to go ahead and graph that line. 4 over 3 is about right here. Again, making that a dotted line to represent the asymptote. Oops, don't know what happened there. So there is that vertical asymptote labeled. Okay, to find the x-intercept, I'm going to plug in, I'm going to set the numerator equal to 0. So negative 2x equals 7. Divide by negative 2, x equals negative 7 over 2, or about negative 3 point, well, exactly negative 3.5. So that's where it's going to intersect with the x-axis. So here's my x-axis. So I go negative 3.5 and plot that point. The y-intercept, I will set everything equal to 0, or all the x's equal to 0. So we get 7 over 4, which is a positive 1.75. So I'm going to go on here and graph 1.75. Why did I? Oh, because this is supposed to be negative 3.5. There we go. So I'll go ahead and graph those curves. Just change the color just for clarity's sake. Well, that's not helpful. Get dark blue. So it's going to approach those asymptotes, go through both of those intercepts, and then continue up and approach that other asymptote. And then we'll have one over in this area as well. So we'll just draw that in. So that is our function. Okay, that's it for the review.